So next concept that we are going to extend into 3 dimensions is the idea of a circle being extended into 3 dimensions. In 2 dimensions, a circle is the set of all points that are the same distance away from a given point. Now, a sphere is going to be the same thing, just in 3 dimensions. So a sphere is the set of all points in 3 dimensions that are the same distance, that distance being the radius, from a given point. And that point is known as the center. Now, to draw ourselves an effective sphere, first thing we're going to do is start with a circle, with a shout out to my alma mater, Albion College. Go Brits. I'm going to do that all the way around, like so. All the way around. Good job, me. Looks very much like a circle, two-dimensional thing. Now, we can give it a third dimension by drawing a great circle around the center of the circle, like you would the equator. And then we can also draw in a couple poles and maybe some extra circles around like this. Make it look a little bit more three-dimensional by adding in some shading like this. Again, drawing three-dimensional renderings on a two-dimensional surface is a bit difficult. So we'll identify the center here and any point that is on the surface of the sphere. Like we'll use this one right here. This distance, straight line distance, from the center to this point that's actually on the sphere. The point that's on the sphere we're going to refer to as the ordered triple XYZ. And for the center, we are going to go with the ordered triple ABC. Now, I've seen some other notations in other textbooks, but ours makes use of ABC. I've seen HKL before because somebody didn't know how to alphabet, I guess. Now, regardless of anything, what should be true is that this distance from the center to any point on the sphere is going to be the same. Now, what we're going to do is make use of a form of the distance formula. So, by a variation of the distance formula. We're going to come up with the standard form for our sphere. So, the change in x will define these 3 points as our x2, y2, z2, and these points as our x1, y1, z1. So this will be x minus a, quantity squared, plus y minus b, quantity squared, plus z minus c, quantity squared, is equal to our radius squared. Normally for the distance formula we would take the square root of both sides and just have a big old radical on this side, but we're not going to worry about that. So this is known as standard form of a sphere. Standard form of a sphere. So just by looking at this, we should be able to tell where is the center of the sphere and what the radius of the sphere is. Next, we'll work through a couple of examples using this formula and these concepts.